Here's the second video simplifying monomials. We're looking at two different problems, and one problem in particular similar to that of the first example, the first video that I did just now, except it's written a different way. Instead of having it in a fraction form, we have a division symbol here. We're going to go ahead and start off with the first one. The idea is to get rid of parentheses when possible. So this exponent applies to everything before it. So we're looking at just what's inside the parentheses. So this is negative 2 to the third power. Negative 2 to the third power is the same thing as 2 times 2 times 2, but it's going to be a negative because we have an odd exponent. So negative 2 times negative 2 times negative 2 is going to give me negative 8. And then when I have x squared to the third power, I'm going to multiply my exponent, so that gives me x to the 6th. And we're multiplying that by 2x. I'm going to go ahead and simplify. Negative 8 times 2 is negative 16. X, since this is to the first power, whenever we multiply like this, we're going to add our exponents. So it's going to give me an exponent of 7. As for the next one, if you want to go ahead and divide like this, we can. But if you would like to rewrite it as a fraction where this is over this, you can do that as well. So we have 8 divided by 4. That's going to give us 2. We have x squared divided by x. That's the same thing as dividing by x to the first power. We subtract the exponents. So it gives me an exponent of 1, which is just x. Y divided by, we don't have a y here, so we're just going to leave the y where it is. Z squared divided by z squared. If you subtract the exponents, you get 0. Anything to the 0 power is 1, so there is no z value. This ends up being our final answer.